This is the second video for October 11th, October 12th, and we're looking at the inverse trig functions. So I think where we left off on the first video is that we graphed arc sine or sine inverse of x, and we decided in order for this to be a function, we have to start here at pi over 2 and go down here to negative pi over 2. If we kept going, it would not be a function because it would not pass the vertical line test. Like here, it would touch the function here and there. That's not a function, so we have to stop it there. And now what we can say is f of 0, if we look at the function, f of 0 is 0. So these go away now, which is what we want. We want one output for every input. And so this is a function. Now let's talk about domain and range of this function. If we're talking about domain of sine inverse, we're talking about the domain of this part of the function. In domain, if we're looking at the x values, we're looking at how far away, like if we go to the left, it goes as far as -1, and it stops in +1. And it touches at this value here. We can actually plug -1 into the function. So our domain is -1 to 1. And our range, well, it goes down to negative pi over 2 and up to pi over 2. It also touches at these values. And so our range is negative pi over 2 to pi over 2. Now we need to make a connection here. If we look at the original parent function sine of x, our domain, hopefully you remember because it goes forever in both directions, is -infinity to infinity, and the range was -1 to 1. Well, since these are inverses, we're actually going to take our range, and that's going to be our new input. Our output of our original function is the input of our inverse function. And so what should happen is the range, this domain and range should be the same. However, they're not the same because we have to constrict it. We have to do a constriction, and the main reason for this constriction, the main reason our range is not -infinity to infinity, is because if it were, like here, if the dotted line, if that was our function, then it would be -infinity to infinity. But we have to pare it down so that we have a function, which is this pink line here. And so because this is a function, this is our inverse function, our range and domain aren't the same, so that we can have a function. All right. Pause it, ask questions outside of class if you need to. Let's go ahead and define a few things. So here, sine y equals x. Then what we say is arc cosine, or arc sine, sorry, of x equals y. And we said that the domain is -1 to 1, and our range is negative pi over 2 to pi over 2. For cosine, similar thing. Arc cosine of x would equal y based off of this. We could also call this cosine inverse of x. Now we could graph this, but let's just make an observation. If we have cosine of x, our domain is -infinity to infinity, and our range is -1 to 1 of the cosine parent function. So our domain, our range here should be our input here, because that's inverse. We switch our input and output. So our domain is -1 to 1, and our domain here should be our range there. But that's not the case for that, because we have to do a constriction so that we have a function. Now, if you go from negative pi over 2 to pi over 2, you would actually repeat, because your cosine values stay positive from negative pi over 2 to pi over 2. And so our range here is actually 0 to pi. This is really hard to explain over video without actually having a unit circle and being able to look at both at the same time. So if you have questions on why that's the range, essentially from 0, if you, like on the unit circle, from 0 to pi, in this first quadrant, all of our cosine values are positive. In the second quadrant, all of our cosine values are negative. We want positive and negative values, and so that's why we go from 0 to pi. Now, tangent, similar thing, arc, tangent of x equals y. This is the same thing as tangent inverse. For our tangent function, our domain was different. We said that x cannot equal positive and negative pi over 2, positive and negative 3 pi over 2 because tangent is, and so on, because tangent is undefined there. But our range is negative infinity to infinity. So our range, our domain here should be related to the range, and it is. Our domain here is negative infinity to infinity. Our range should be related to the domain, and it is, but not fully. And what our range is parentheses, not brackets, parentheses, negative pi over 2 to pi over 2. Similar thing with these two. And from negative pi over 2 to pi over 2, tangent is negative all in quadrant 4. Tangent is positive all in quadrant 1. So we get all the values for tangent. Also, they're parentheses because in our domain, x could not equal positive or negative pi over 2, which means it does not touch, which is where the parentheses come from. All right. I would highly recommend pausing it, asking questions if you don't understand anything here. Also, I would highly recommend on your own time, maybe not for arc tangent, but for arc cosine. I could ask this exact same question on an assessment for you to explain the domain and range and the restrictions for arc cosine. So for example, if I give you that cosine's domain and range is this, arc cosine's domain and range is this, where do the domain and range come from? How are these two related? I could ask that question. So maybe spend some time here writing out some words on the relationship there. Now, real quick, I'm going to show you how this works, and then this will be the last part of the video. So I'm just going to do tangent. We could also do sine or cosine. I'm just going to show you tangent. So here we have an angle theta. We know from SOHCAHTOA, however you want to say it, that tangent of our angle theta would be opposite over adjacent. That's what the O and the A stand for. So tangent of theta is 5 over 3. Now, just like if we were to want to solve 5x equals 35, x here equals 7, because we do the inverse operations. It's 5 times x, so we divide both sides by 5, and we get x equals 7. Well, similar thing here. We have theta there, and we actually want to get theta on its own. So we want to solve this equation for theta. And the way we do that, we would take the inverse of tangent. Well, the inverse of tangent is tangent inverse. And so theta, if we took the tangent inverse of both sides, if you will, that would be 5 over 3. And so theta would be tangent inverse of 5 over 3. Essentially, tangent, sine, cosine, tangent, those are ratios of the sides of a triangle. Okay? Whereas the inverse functions, tangent inverse, sine inverse, cosine inverse, they're functions that give us the angles in relation to the sides. So that's how we'll use it. We'll see more practical use of this on October 13th and 14th. Also, October 17th through the 20th, we'll also see more application of this. If you have questions, please feel free to email me, contact me anytime. I'm glad to answer those questions.